All right, this is chapter 1, lesson 9, estimate roots. Okay, so the first thing I want to do is I'm wanting to figure out how to estimate square and cube roots. So last lesson we dealt with strictly perfect squares and perfect cubes. Okay, so we know that the square root of 8 is not a whole number because 8's not a perfect square, right? 8's a perfect cube, but it's not a perfect square. So the number line below shows that the square root of 8 is somewhere between 2, right? So the square root of 4 is 2, and the square root of 9 is 3. Somewhere between 2 and 3. Now the square root of 8 is probably going to be closer to 3 than it is to 2, right? Since 8 is closer to 9 than 4, the best whole number estimate for the square root of 8 is going to be 3. All right? So we're going to go ahead and look at some sample problems. All right, and then you're going to try some on your own. All right, and we'll go over another one a little bit later. So the first problem I have, problem 1, it says estimate 83 to the nearest integer. So I'm looking for the nearest whole number. So I want to look at the largest perfect square. So remember that square root chart that I gave you on the previous page? See that? You're going to want to use that, okay? So the largest perfect square less than 83 is 81, so that's 9. And the smallest perfect square greater than 83 is 100, and that's 10. So I can plot each square root on a number line, then I can estimate it. So I have 81 and 100, somewhere between 9 and 10. 81 is probably closer to 83 than 100 is. So my estimate is going to be closer to 9. Okay, that's what all this says. So 81 is less than 83, which is less than 100. So 9 squared is less than 83, which is less than 10 squared. So that means square root of 83 is somewhere between 9 and 10, but it's going to be closer to 9. Okay, so the estimate for the square root of 83 is about 9. All right, so number 2 says estimate the cube root of 320 to the nearest integer, okay? Again, the chart will really come in handy for you. All right, so the largest perfect cube less than 320 is 216, and the smallest perfect cube greater than 320 is 343. So that means my number is going to be between 6 and 7, okay? 320 is closer to 343, so my best estimate is going to be 7. Okay? So you got a couple of try problems over here. There's A, B, and C, and D, E, and F. Go ahead, try them on your own, pause the video, and then once you've tried them, we will go over the answers together. All right, so let's look at the try problems. So the first one I have is A, the square root of 35. So the square root of 35, right? So the ones that I have that are in common are going to be the one less than that is 25 or 36. This is 5. This equals 6. 35 is closer to 36, so my answer is going to be 6. Okay. Looking at letter B is the square root of 170. Okay. So 170 the smaller one is 169, which is 13, and the next is 196, which is 14. So 170 is closer to 169, so I'm going to get 13. Okay. Then I have 44.8. Again, just stick with whole numbers because I'm looking for whole numbers. All right, so 44.8. I have 36 and 49. Okay. 49 minus 44.8 gives me 4.2. And 44.8 minus 36 gives me 8.8, so it's closer to 7. Okay. Then I have D, E, and F. D is the cube root of 62. Okay, so I have cube root of 27, which equals 3, and the cube root of 64, which is 4. 62 is closer to 64, so my answer is 4. Okay. Letter E is the cube root of 25. So I have cube root of 8, which is 2, or the cube root of 27, which is 3. 25 is closer to 27. So 3 is my answer. Okay. Then I have cube root of 129.6. So I have cube root of 64, which is 4, or the cube root of, cube root of 125, which is 5, and then the cube root of 216, which is 6. Okay, 125 is closer to 129.6, so I'm going to get 5. All right. Looking at the next page, I have example number 3. Okay. So example number 3 says, Wyatt wants to fence in a square portion of the yard to make a play area for his new puppy. The area covered is 2 square meters. How much fencing should Wyatt buy? Okay, so over here I have my square, 2 square meters, right? Wyatt will need 4 times the square root of 2 meters of fencing. The square root of 2 is between 1 and 2, so 4 times the square root of 2 is between 4 and 8. Is this the best approximation? You can truncate the decimal expansion of square root of 2 to find better approximations. So, estimate the square root of 2 by truncating, which means truncating just means to stop, okay? So, or dropping the digits after the first decimal place, then after the second decimal place, and so on until an appropriate approximation is reached. So the square root of 2 is 1.414213562. You can use a calculator for it, okay? So I can basically cross a lot of those out, and I can do 1.4, okay? Okay. So that means somewhere between 5.6, right? Because 4 times 1.4, somewhere in between this. So I have 5.6 and 6, somewhere between that, right? So if I wanted to find an even closer approximation, I could expand the square root of 2, then truncate the decimal expansion after the first 2 decimal points. So 1.41. So 4 times 1.41 is 5.54. So I could go 5.64 between 5.68. So the approximations indicate that Wyatt should buy 6 meters of fencing. Okay? All right, so let's try it. Go ahead and read the try problem by yourself. Pause the video. When you come back, we will go over the answer together. So letter G states Kelly needs to put trim around a circular tablecloth with a diameter of 36 inches. Use the equation C equals pi times D to find 3 sets of approximations for the amount of trim she will need. Truncate the value of pi to the ones, tenths, and hundredths place, then determine how much trim she should buy. okay? So diameter is 36 inches, okay? So I want to figure out the circumference. Okay. In order to do this, I want to find 3 sets of approximations. So truncate pi to the ones. So pi 3.141. It can keep going. 592654. Okay. So pi times d, so first thing I want to do is I want to take 36 times 3, because that's the circumference. So 36 times 3 gives me 108. Okay. Then I want to take 36 times 3.1. It's me 111.6. Then I'm going to take 36 times 3.14. 113.04. Okay. So as you can see, they get a little bit more. They get a little bit closer. These are closer together. These are closer together, and so on and so forth. So the more you go out, so if I were to take 36 times pi on a calculator, so this is 36 times pi equals 113.0973355. Okay, and it would continue on forever because pi never ends. It's an irrational number. It never ends and never repeats. So I would guess that she'd probably need 114 inches of trim. Okay? So she needs about 114 inches of trim because that's going to be our best approximation. And that is the end of lesson 9.